logarithmic function. So the logarithmic function, as we talked about in the last video, its whole purpose in life, and the whole reason for its existence, is to solve the inverse of the exponential function so that we can solve for the exponent, right? That's the only, so it was created to do that. All right, so again, it has to do with the exponential function a raised to the x, y equals a raised to the x, and so it is the function, the flip of that, where you take x and y and you flip it, so it's x equals a to the y, which that's its inverse notation. But again, there is no algebraic way to solve for the y to put it in the function notation, so they created a function that'll do that because they know it exists. It's provable because exponential is 1 to 1, ergo it has to have an inverse. Its inverse exists, it satisfies this equation, and so we gave it its own name. And again, don't get bogged down on the log part. The log part is just solving for the exponent. That's what the log is. Alright, so the a in the logarithmic function, just like the a in the exponential function, is the base of the log. Right, log base a, exponential function base a. So the function f of x, which x a base, and g of x, which is the natural log base a, are inverses by design. Actually, that's first where they were discovered, and then it was created because they were inverses. Alright, so what we do is sometimes the easiest way to solve it is to go from logarithmic form to its exponential form, or vice versa, exponential form to its logarithmic form. Alright, so the logarithmic form, y equals the natural log of x, is the same as the exponential inverse form, right? X equals a to the y. The log is just a way to represent solving for the exponent. The log is an equation that is an exponent. It is the exponent y. Alright, so the log of x with respect to base a, so kind of how you read this logarithm. It's the log of x with respect to base a is the exponent to which a must be raised to obtain x. So the y is the exponent that you have to take base a in order to get the x value in the middle. Right? And a couple common logs, and we'll talk more about these common logs. They're common, so they actually show up on your calculator, is the log base 10. That's what this first one is, log base 10. Log base 10 of x is equivalent to 10 raised to the y equals x. So again, the y part is what exponent do I put on 10 to get out the x value. And so it's a common, so these would be your common logs, what we call common logs. Alright, the log base 10 and base e, which again, both of those, and we'll talk more about these later on, because we have an alternative notation that shows up on the calculator, but when we get to that, we'll talk about it. But those are what we call our common logs. So, just to kind of do a simple example over here, y equals log base 10 of 100 is equivalent to, that actually arrow means equivalent to, 10 to the y equals 100. Well, what does y have to be? Well, what do I have to raise the 10 to make it equal to 100? Well, it has to be 2, right? 10 squared equals 100. And so that logarithm is equal to 2. And so we're just kind of practice that. We're going to use the equivalent expression to solve some basic logarithms. Alright, so evaluate the following by converting to the exponential forms. Try to do this without the calculator, although most scientific and smart calculators will solve logarithms. Other bases besides 10 and e are a little harder to find, but they're on most graphing calculators. But again, we want to do this without the calculator. Alright, so remember, we're looking for the exponent y. And so if I convert this, this is base 10 raised to the y equals 1 over 10. Well, I can rewrite 1 over 10 as 10 raised to the negative 1. And so this has to equal negative 1. Because that's what y has to be. Y has to be negative 1 in order to get 1/10 out. The the next one. To get the next one, same thing. I'm going to rewrite it. So my base is 2. So 2 raised to what exponent gives me out 32? Well, 32 is 2 raised to the 5th, right? If you take 2, raise it to the 5th power, right? So 2 to the 2nd is 4, cubed is 8, to the 4th would be 16, and 16 we'd multiply by another 2 to get us 2 to the 5th, would be 32, and so that means that has to equal, not 2, has to equal 5, right? Because 2 to the 5th equals 32. I guess I should write this one out. 10 to the negative 1 equals 1/10. Alright, the next example, so again, same thing, I'm going to rewrite it. Base 4, so 4 raised to what exponent gives me out 8. Well, this one's a little trickier because there's not an easy way to kind of convert between 4 and 8, right? 4 raised to nothing gives me 8. But I can convert both of them to 2's if I change this to 2 squared, still raised to the y, and I can change 8 to 2 cubed. Right? And then I will rewrite it, and I'm going to come over here when I rewrite it. So this is 2 to the 2nd, that's the same as 4, right? All I did was change 4 to 2 squared. Well, 2 squared is 4. And now I'm going to rewrite it, so it's going to be 2 to the 2 times y, right? When I raise it, I multiply, and that equals 2 cubed. Which tells me, since I have the same base, 2 to the y has to be equal to the cube. Right? So 2y equals 3, and so if I solve for y, I get y equals 3 halves. And check it out, make sure it's right. This comes out 3 halves. And so if I rewrite it, so that says 4 to the 3 halves equals 8, type that in. Take 4 into your calculator, take 4, raise it to the 3 halves, not the whatever I had written there, 3 halves. It should come out 8, and it does. Right? It will be the square root, if I do it by hand, it would be the square root of 4 cubed. Square root of 4 cubed comes out 2 cubed, which is 8, so it does check. But you could plug it into your calculator and check it too. Alright, the next one. So again, rewrite it. 8 is my base. 8 to the y equals 2. Alright, 8 to the y equals 2. So I know this is going to probably be a fractional power. So again, same idea as what I did in the last example, although I erased what I had there. I'm going to change 8 to a 2. Well, 8 is the same as 2 cubed, right? If I take 2 cubed, that's equal to 8. So I haven't changed anything other than rewriting 8 as 2 cubed. Still equal to 2. And so when I multiply my 3 times y, this is 2 to the 3y. So 8 to the y is exactly the same as 2 to the 3y equals 2, which means there's an understood, if it's just 2, there's an understood 1 power up here. And so that means 3y has to equal the 1 on the other side. So the 3y has to equal 1. And so y is equal to 1/3. Right, that's using sort of the math method. And so if I rewrite this, this would 8 to the 1/3 power equals 2, which is correct, right? That's the cube root of 8. Well, the cube root of 8 is 2. Easier, right? So I've got 10 is my base, raised to the y equals, sure I got 3 zeros, not 4 zeros. Alright, well what power on 10 do I put to get 10,000 out? Well, you put a cube. Right? 10 cubed will give me 10,000, so the answer to this is 3. Right? 10 cubed equals 10,000, or 100,000. 10,000 would be 4 cubed. Or 10 to the 4th, not cubed. 10 to the 4th would give me 10,000. 10 cubed gives me 1,000. The next one's a trick. Right, but if we write it out, we'll see what it is. It tricks the wrong way. The next one's a special case. So remember if you remember the definition, you should already know what the answer to this one is. So it's 10 to the y equals negative 3. Well, y is an exponent, and when I put negatives in, I get fractions out. And so remember, a always has to be greater than 0. And so when this plugs in negative numbers, right, 10 to the negative 1 is 1/10, there's no value I can plug in to get a negative number out, right? Exponential functions are always positive. And so the answer to this is no solution, or undefined. Doesn't exist, right? You can't have a negative number in there, undefined. Same thing's going to happen for the next one. Right, base 9. 9 to the y gives me out 0. Well, there's nothing I can plug in for y to make it 0. You can't. You can't plug in anything for y to make it 0. Even 9 to the 0 comes out 1. Alright, so there is no solution to this. So this is undefined. You can't have negatives and you can't have zeros. Right, so you can't find the log of a negative number and you can't find the log of a 0. Those are the last of the two. Those are the only two special cases. So whenever you see a negative number in here or 0 in here, it's always undefined. Alright, next example. 8 to the, so 8 is my base, so 8 to the y equals 1. Well, actually, what I gave you here will give you that answer, right? What power do I get 1 out? Well, the power has to be 0, right? 8 to the 0 gives me 1, so this has to be 0. Alright, next one. Alright, so 10 to the y gives me, and I'm going to rewrite the square root as, again, I keep wanting to add a 0 to that, the half power, right? Because I think it's easier to deal with this when it's the half power. Because that's what I'm actually going to do. I'm going to convert this to a fractional power. So all I did right now is I rewrote it as an exponential, and when I rewrote the square root, I rewrote it as the fractional power 1/2. Alright, then my 10 is the base that I want, and so remember, that is 10 cubed. We did it earlier. And so 10 cubed is 1,000. The square root of that, which is the half power, and if I simplify that, that's 10 to the 3/2. And so y has to be 3/2 in this case. 3/2 would be the answer. And again, if you wrote it out, 10 to the 3/2 is the same as the square root of 1,000. If you type both of those in your calculator, you'll get the exact same answer. Alright, next one involves the base e, which we'll talk about more in a little bit, but that natural number e. So log base e, this means e to the y equals e. Well, what exponent do I put on a function to get out the exact same value? Well, remember there's an understood 1 there, and so y has to be 1. So the answer to this is 1. Alright, the last one. 2 raised to the y equals 1/16. So again, I'm going to manipulate that to, first of all, I'm going to rewrite it as a 16 to the negative 1. And then my 16, sorry, I still have my negative 1 on here, can be rewritten as 2 to the 4th, right? 2 to the 4th is 16. And so that's 2 to the negative 4th. That equals 2 to the negative 4th. And so my y has to be negative 4. If you take 2 raised to the negative 4th, it should equal 1/16, and it does. Alright, and so that's just practicing some logarithm expression. Now, you will get the use of your calculator, so you can go through and redo all of these using your calculator. Alright, but there's a couple of by hand methods just to show you how the logarithm works, because it's really the inverse of the exponential function. So in reality, the best way to sort of understand it is to understand it as the inverse of the exponential and use our exponential rules to solve. Alright, we'll stop there. We'll pick up the next set of notes in the next video.